Hello there, welcome to my channel. Today we're going to be solving a really nice exponential equation involving a radical. So first of all, let's go ahead and start with the domain of this equation. Obviously, we want this expression to be non-negative, and the same thing is true for this one. So we have two restrictions. We want 35 to the x minus 49 to the x to be non-negative, and we want 5 to the x minus 7 to the x to be non-negative as well. So from the first one, we can say that 7 to the x times 5 to the x minus 7 to the x times 7 to the x is non-negative. Next, we can go ahead and factor out 7 to the x. And if we do so, we're going to get 7 to the x times 5 to the x minus 7 to the x. And we want this expression to be non-negative, but notice that we know that 7 to the x is always positive. So if you want the whole thing to be non-negative, we just need to have 5 to the x minus 7 to the x non-negative. So if this is non-negative, then the whole thing is going to be non-negative. And if you look at this, you can see that this restriction is the same thing as this one. So both of these restrictions mean the same thing, and they are the same thing. So we only have one restriction and not two restrictions. So we want 5 to the x minus 7 to the x to be non-negative, and that means that 5 to the x should be greater than or equal to 7 to the x. And this is possible if x is less than or equal to 0. Because for negative exponents, 5 to the x is greater than 7 to the x, and for x equals 0, they are equal. Great, so we want x to be less than or equal to 0. So let's go ahead and solve our equation considering this restriction. Let me rewrite our problem. So we have 5 to the x minus 7 to the x equals the square root of 35 to the x minus 49 to the x. And we know that x should be less than or equal to 0. Now, in order to solve this, let's go ahead and square both sides to get rid of the radical. So we're going to get 5 to the x squared plus, actually minus, 2 times 5 to the x times 7 to the x plus 7 to the x squared equals 35 to the x minus 49 to the x, which can be written as 7 to the x times 5 to the x minus 7 to the x squared. Next, let's go ahead and move everything on the same side. So we're going to have 5 to the x squared minus 3 times 5 to the x times 7 to the x plus 2 times 7 to the x squared equals 0. Now, if you look at this, this is a really nice homogeneous equation. And in order to solve this, we need to go ahead and divide both sides by 7 to the x squared. So we need to divide both sides by 7 to the x squared. By doing that, we're going to get a really nice equation. Actually, we're going to get a really nice quadratic equation. So let's go ahead and do that. We're going to have 5 to the x squared divided by 7 to the x squared minus 3 times 5 to the x times 7 to the x divided by 7 to the x squared plus 2 times 7 to the x squared over 7 to the x squared. Obviously, we can simplify this, and we can simplify it into 5 over 7 to the x and then squared minus 3 times 5 over 7 to the x plus 2 equals 0. Next, we're going to use the substitution method because we can go ahead and substitute this with something like u, and from that we can say that this is u squared, and by doing that we're going to get a simple quadratic equation. So we get u squared minus 3u plus 2 equals 0. Obviously, we can factor out the left-hand side into u minus 1 times u minus 2. And this means that u is equal to 1 or it is equal to 2. So if u equals 1, we're going to have 5 over 7 to the x equals 1, which means that x equals 0. But remember that x should be less than or equal to 0, and 0 is less than or equal to 0, therefore it is a valid solution. Next, if u equals 2, we're going to have 5 over 7 to the x equals 2. Obviously, by using the definition of logarithm, we can go ahead and say that x equals log of 2 with base 5 over 7. But the question is this a valid solution or it is not? Or a better question is this number negative or it is positive? So let's go ahead and find that out. Obviously, if x is log 2 with base 5 over 7, we can go ahead and use the change of base formula and write this as log 2 with base 10 over log of 5 over 7 with base 10. Then we can rewrite the bottom as log 5 minus log 7. Now, obviously, log 2 is positive, but since log 7 is greater than log 5, this is negative. Therefore, the whole fraction is negative. So this number is negative, and therefore, this is a valid solution to our equation. So we have two solutions, this one and this one. And this brings us to the end of this video. Thank you for watching this. If you enjoyed watching this, hit the subscribe button and hit the like button, and I'll see you later.